Hello and welcome. Today I will continue my series of videos about different aspects of JWT tokens, and I will explain a JWT token workflow in details from practical standpoint based on golden application and how to debug different problems related to JWT tokens. You can find a link to my video with explanation of general aspects of JWT tokens here or in description below this video. A link to GitHub repository with source code of Go application you can find below. Usually, I prefer to prepare my videos based on the real situations that I face in my day-to-day practice. And this is one of those cases. First, let's walk through the typical authentication flow that happens when using JWTs in an application. The process starts when a user enters their credentials, typically a username and password on your application's login page. Once the server receives the login request, it verifies the user's credentials. If they valid, the server generates a JWT token, which is a signed token containing claims, such as the user's identity and roles. This token is created using a secret key or public-private key pair, depending on the algorithm used, for example, HS256 or RS256. The server then returns the JWT token to the client, usually in the response body or as part of a secure HTTP response header. The client typically stores this token in local storage or cookies, depending on the specific use case and secure requirement. For every subsequent request, the client sends the JWT token to the server, for example, REST API server, as part of the HTTP authorization header. This is how the client proves its identity without having to re-enter credentials. The authorization header typically looks like next one. After receiving the JWT token, the server decodes and verifies the token. It checks the signature, the expiration time, and ensures that the token is valid. If everything is okay, the server grants the client access to the requested resources. This process allows for stateless authentication, meaning the server doesn't have to store sessions data. Everything the server needs to authenticate and authorize the user is in the JWT token itself. Now, let's talk about refresh tokens, a critical part of JWT authentication. In a typical scenario, JWTs are designed to be short-lived for security reasons. This means once a JWT token expires, for example after 15 minutes, the client can no longer use it to authenticate requests. This is where refresh token comes in handy. A refresh token is typically issued alongside the JWT token, but it has a longer lifespan. For example, days or even weeks. When the JWT token expires, the client sends the refresh token to a refresh endpoint on the server. The server verifies the refresh token, and if it's valid, it generates a new JWT token and sends it back to the client. This allows the user to continue interaction with the application without having to log in again, even if the JWT has expired. Refresh tokens offer a balance between security and user experience. By using short-lived JWTs and long-lived refresh tokens, you can ensure that sensitive data is not exposed for too long, but you also avoid requiring users to log in frequently. Let's now dive into how to implement JWT in whole-length applications. To generate a JWT token, we can use libraries that abstract the complexity of the process. For instance, If you're using a Golang, the Golang JWT library is a common choice. In Golang, the process might look like next one. In this block of source code, we add the appropriate Golang library. After that, we should create a new JWT token. And finally, we should assign the token with a secret key. Once the client sends the JWT token, the server needs to verify it. In Golang, this can be done using the same Golang JWT library, like in the next block of code. This code checks that the token is valid and hasn't been tampered with. If the token is expired or invalid, you would typically return a 401 unauthorized response. For RESTfull APIs, JWTs are perfect for stateless authentication. Each API request can include the JWT token in the authorization header, allowing the server to easily authenticate the client and provide access to protected roles. For example, after authentication the user and issuing a JWT, the client can make a request like this. The server will then extract the JWT token from the authorization header, verify it, and grant or deny access based on the claims inside JWT. While JWTs are powerful, they come with their own set of issues that you may encounter during development. Let's go over the few common problems and how to solve them. One of the most common issues with JWTs is expired tokens. Since JWTs contain an exp claim, they have a defined expiration time. If client tries to use an expired JWT, the server will reject it. To handle this, you'll need to implement refresh token to renew the JWT when it expires. If the signature of the JWT is tampered with, the server will detect that the signature doesn't match the expected one and will reject the token. To fix this, ensure that your secret keys are stored securely and are not exposed to unauthorized users. Sometimes, JWT might be missing important claims or might not be correctly formatted. This often happens due to incorrect encoding or improper token creation. You can use tools like JWT.io debugger to decode and validate tokens, which can help you identify missing or malformed claims. If you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. Thank you for watching and see you next time.